Hello, this is Mr. Tolbert and Mr. Tolbert's physical science class. This is lesson number 5. This is chapter 10, lesson number 5. Chapter 10, lesson 5. In the previous chapters, we've discussed how everything's composed of atoms, and all these atoms are always moving, and in that movement, they're either attracted to each other or not. The faster they move, the higher the temperature. That gives us also what state of matter they're in. So here we are. Here are the 4 states of matter. The most common state of matter in the universe is plasma. Please asterisk that or circle that. That is a test question. The most common state is plasma, because that fiery ball in the sky called the sun is a plasma. Lots of mass, so there's a lot of it that's plasma. You're also used to plasma. You're talking about televisions and things of that nature. But anyway, so here are the 4 states of the matter. Solid, liquid, gas, plasma. All of that has to do with how fast exactly is the source moving. Solids can be hard like rock or soft like fur. Big like an asteroid or small like grains of sand. The key is that solids hold their shape and they don't flow like a liquid. A rock will always look like a rock unless something happens to it. The same goes for a diamond. Solids can hold their shape because of their molecules are so tightly packed together. They have a very high intermolecular force because they're not moving. They're just jiggling back and forth with that thermal energy. So they're attracted to each other, keeping each other cozy right next to each other. Liquids feel the shape of any container they're in. Liquids have a definite volume but an indefinite shape. Liquids can flow. Liquids, as you heat up a solid, the solid they do more than jiggle, they start to get away from each other. As they move away from each other, it becomes a liquid. And this liquid has space between the molecules, more space than you would have in a solid, but not a lot of space. But the intermolecular force is definitely less than that of the intermolecular force inside of a solid, because things are moving now. Gases can fill a container of any size or shape. It doesn't matter how big the container is. The molecules are going to spread out to occupy all of the space equally. So whenever you blow up a balloon, you blow it all up. You don't just blow up the left side of it or the right side or just the middle. You blow it up and the whole thing starts to expand simultaneously as you blow it up, because that's the gas from your lung that you're pushing into it, filling all the available space. Plasma is really exciting because plasma is the most abundant state of matter in the universe. There are different and unique forms of matter. Plasma is different than a gas because it's made from groups of positively and negatively charged particles. So this has to do with these electrons. And as you speed a gas up well beyond its natural speed limit, you start to do crazy things to its electrons. And as these electrons are moving, that causes them to change the polarity, if you will, of the atoms. So those atoms are no longer neutral. They can become positive or they could become negative. And because they're positive and negative, there's a lot of different things that we can see, a lot of things that we can witness and use to our advantage. It is the thing that we use in light bulbs and televisions, and yes, the sun is a plasma. Temperature change. Temperature change has to do with the speed of the atoms, solid, liquid, and gas. As you move from a solid to a gas, you are increasing the temperature. As you're increasing the temperature, the motion of the atoms is greater. Greater the movement, greater the temperature. As you move down from a gas all the way down into a solid, it's moving slower and slower. Temperature allows us to change the phase of matter. We call phase change basically the state change. Here's a great example of the states of matter, kind of how they're like locked into strong bonds in a solid, liquids not as strong as bonds, gas no real bonds, and ionization of plasma. States of matter are physically different. Gas is free, as we've already said, to flow in all directions. Gas can exert pressure. Solids have a rigid structure. Liquids take the shape of the container. All of this has to do with energy. Let's look at this picture for a moment. Remember, as you heat something up, you are adding energy. As you cool something down, you're taking away energy. Energy is the key. Energy. Energy is the ability to move or change matter, the ability to do work. Energy cannot be created nor destroyed. Thus, we know that as the law of conservation of energy. Energy is either used to do work on molecules, moving them out of the crystal lattice at the melting point, or moving them further from each other into a gas state at the boiling point. This will be the beginning of the second half of Lesson 5. I'm going to stop right here, and I will start a new video for the next one.